the next case study, that what I want to be discussing is a poor response time from a very major cloud service provider. There's a very high chance several of you in this call may be using their service, right? What was happening? It was having a poor response time. They didn't know why. So, and think about it, we are building our services on these cloud service providers, and they themselves are having a poor response time. And this problem surfaced because of the garbage collection on that service provider service. So garbage collection, friends, is often an underdog. A lot of us, we dismiss it. We don't look at it at a great sense. So it's always often dismissed. But it is a silent killer. It can have an heavy impact on your performance of your application. But if you can tune it, you can take it for your advantage and you can reap significant rewards. So now let's talk about a little bit about that. So what is garbage? So you can see, friends, our application memory is a finite space, right? Our JVM, we set up our XMX, the heap size as 2 GB, 4 GB, 10 GB, 20 GB. Even if you set it to 1 terabyte, still it is a finite space. 1 terabyte is still a finite space. So when a new request comes to your application, this request is going to create a lot of objects in our memory. Let's say the simple sign-on request comes in. Say for the sign-on request, what are the objects it's going to create? It's going to create a servlet request, HTTP request object, servlet object, response object. The request object is going to contain a customer object, which is going to contain a username. Since the sign-on request is going to contain a username and a password. So those are objects. And now my application is going to create a controller object. Now it's going to create a data access object, a connection object, and now it's going to make a backend database call. The database call is going to give me back a result set, which is an object. So we end up creating tons of objects in memory. So now I create all those objects. Now I service the request. Okay, so now the request goes away. The JVM has serviced the request. Now the request goes away. Now what will happen to the objects that got created here? The request is gone. There's no one is having an active reference to these objects. So now these objects becomes garbage, right? It's garbage. It's of no more use. It has to be removed from memory. It has to be evicted from the memory. Only after you evict from the memory, the room is going to be made for processing other incoming request, right? So now this is garbage. How is this garbage collected? How is this garbage removed from the memory? Friends, 3-4 decades back, as a developer, say suppose if I was programming in C, C++ back in those 3-4 decades back, as a developer, it is my responsibility to write a code to manually deallocate the objects I created. So say suppose a new request comes, I create a customer object. Once that request goes away, it is my responsibility to remove that object from memory. I need to write a code for it. Friends, as you can envision, the business is very complex. The business has multiple workflows, multiple use cases. Even if I miss in one particular use case, if I miss to deallocate the object, then those objects are going to build up in memory. And if it builds up in memory, then I'm going to get a memory leak and I'm going to get an out-of-memory error. So the memory leak and out-of-memory error was pretty pervasive back in the days. So when Java came in 1995, right, Java promised, hello friends, you guys, the developers, hello developers, you guys don't worry about deallocating the objects. You only create the objects. It's my responsibility as a runtime environment to remove the objects from memory. So JVM gave that promise and then it did it. It went about recollecting these objects automatically. Since then, even there were languages even before Java, they were doing this automatic garbage collection. But once Java came into this, it became this automatic garbage collection came into mainstream. And since then, all the language which is coming has this automatic garbage collection capability. It doesn't matter whether you're working on Python, .NET, all these languages, Golang, all of them has this automatic garbage collection, which is a wonderful thing, But this automatic garbage collection has a couple of side effects. What are those side effects? First one is it pauses your application. That is, it stops your application. This automatic garbage collection needs to stop your application. See, because your application is created objects. So now the garbage collector, to find what are all the inactive objects, which is not referenced, it stops your application. It pauses your application in the middle. When the customer transaction is coming, it's going to stop. And then now it's going to investigate your memory to see what are the active objects, what are the inactive objects. If they're inactive, it's going to remove it. It's to do that, it stops your application. That is the first side effect. That means if any customer transactions comes when the garbage collection is running, he's not going to get response. If your customer says, oh, your application was running fine, but in all of a sudden it didn't respond, but few seconds later it started to respond, it means very likely the garbage collection is running in the background. That is the first side effect. The second side effect is, friends, garbage collection consumes enormous amount of CPU cycles. Yes, because it has to investigate all these millions of objects which is there in memory. It consumes enormous amount of CPU cycles. I'm sharing a link to a case study where Uber, a car ride-sharing agent, ride-sharing app, they had a pretty significant garbage. Due to garbage collection, the CPU cycles was very heavy, and they did a GC tuning, and they were able to reduce their CPU consumption by 700,000 crores, which resulted in several millions of dollars in cost savings for them. It is a pretty huge impact, right? So these are two side effects of this automatic garbage collection. So now this cloud service provider in which we are all running our services, right? One of the primary service provider, they had a slowdown, they had a poor response time. So here in this, once again, they ran the script and then they got the data. Here, what helped them to rescue is this garbage collection log. This GC log helped them to rescue the situation. How does the GC log looks? This is how a GC log looks. You can open up in a text file and then you can look at it. Okay, you can see, okay, these are all, this is how it looks. It's pretty cryptic file. It's not very trivial to look at it and analyze it. So you are welcome to use, these are some of the tools available in the market to analyze the GC log. So Ycrash and GCeasy is from our company, but there are also other tools are available. So you're welcome to use whatever you prefer, right? So take the GC log and do the analysis. So now what we will do, we will look at the actual GC log of the cloud service provider, the critical service, what it was doing. So now let's take the GC log and let's analyze this, the actual data. The GCeasy tool is available online, or also it's available, you can install it locally and then do the analysis. So now I'm going to be uploading that actual GC log file. Let me do that. Okay. So now I uploaded. So at the top, if there are any problems found, it's going to report all the problems. Any recommendations to improve it, it's going to give those things. But friends, here, look at this. Yes. See, here there in this graph, in this analysis report, the GC log analysis report, here you can see what is the GC duration, how much time your GC events are taking to complete. That means if any GC event, here, look at this. So here, there is one GC event which ran at 8:26 a.m. It took 12.56 seconds. This GC event took 12.56 seconds at 8:26. If any transactions that came to this to this cloud service provider, to this service, at this 12.56 seconds, if it came at 8:26, it will not get the response for next to 12 seconds because garbage collection is running. Only after this garbage collection completes, the customer is going to get response. Look at this, my friends, all throughout the day. Look, it's having like a 14 seconds pause times continuously. And we are all running our services on these cloud service providers who is having such an exorbitant pause time. If this provider itself is suffering from such a poor pause time, how is my SLA going to be? It's going to be worse than this. So this is what was going on here. So friends, when you do the GC analysis, there is one KPI, key performance metric, called as throughput, GC throughput. Look at what is the throughput of this cloud provider. It is 96%. What does this throughput means? Let me explain it so that you guys follow this, right? What is, when someone says 96% throughput, how does it sound to you guys? Say if someone comes and say, oh, my application throughput is 96%, how does it sound? For most of us, it sounds good, right? Because if my high school daughter, if she gets 96%, which is a A plus grade, I'm very happy, right? But I want to see who is this gentleman or the woman who coined to report this throughput in percentage. He's a very clever man. I want to see him once in my lifetime, right? But this is a very deceiving number, my friends. It's very deceiving. Let me explain why this is. When someone says GC throughput is 96%, what it means is this application is spending 96% of its time in processing customer transactions. Remaining 4% of time is spent in processing GC activity. This is what, when someone says 96% throughput, it means your application is spending 96% of its runtime in processing the customer transactions. Remaining 4% in processing the GC activity. What is 4% in 24 hours? If my JVM is running for 24 hours, what is 4%? Let's look at it. 1 hour, 1 day as 24 hours, multiply, let's do the calculation in minutes. It has like a 1,440 minutes. What is 4% of that? Let's do that. 57.6 minutes. It means 4%, it means 96% throughput means 57.6 minutes my application is spending in garbage collection. 57.6 minutes in 1 day. That means 1 hour I'm spending in garbage collection. That means during this 1 hour, if any request comes, they're not going to get any response. And this is just one JVM. If you have a huge deployment like 100,000 JVM or thousands of JVM, multiply 1 hour by those 100,000 JVM. What is the cost we are wasting today, right? It's pretty, but they hide it. Reporting as a percentage looks very nice. But if I'm going to say 1 hour per JVM, every day you are wasting, you're doing garbage collection, not processing any customer transaction. It's a shock. Do you guys see what I'm saying? So that's what was happening here. Very bad because the process was very high. They're having a very poor throughput. Now, because of the recommendations they followed, given in this tool, what they did, look at this, friends. In JVM has multiple internal regions. The JVM memory has multiple internal regions. One of them is a young generation, other is a old generation, and the meta space, right? See, they kept the young generation size and the old generation size as same. Look at this, it's set as 14.65 GB and 14.65 GB. Based on the recommendation they see, they reduce their young generation size. Once they reduce the young generation size, let's look at how was the GC behavior. Now I'm going to upload the GC log once they reduce the young generation size, a minor GC setting change. Let's look at it. So now I'm uploading that GC log file. Okay, so now I uploaded. Now, boom, look at this. What happened to my throughput? It went to 99%, 99.36%. And let's look at the pause times. See, most of the pause times have become like a milliseconds range. There are few, which is there a 2-second range, which is not okay. It is okay, which only few times it is happening in a day. But predominantly it is fallen to milliseconds range. Just this minor setting change helped them to reduce their overall response time, right? And then the SLA became better. Friends, a lot of us, we ignore GC tuning, but GC tuning is a very significant part when it comes to JVM performance. Because in this deck, I cannot go into the details. You can see Uber saved millions of dollars because of GC tuning. A very large automobile manufacturer, I cannot tell the name, they were able to improve the response. And there's so many enough case studies to for you to look at it. Friends, a lot of us, the GC just slips through, but the world is wasting billions and billions of dollars in garbage collection. Because when garbage collection is happening, I'm not processing my customer transactions, but still my cloud provider, I need to pay to them, right? So yeah, but there are some tech smart savvy. So here is a tweet made by one of the very large SaaS CEO, Zogo. He's a tech He's a technical CEO. So he's making, this was his tweet, I'm quoting. Look at this. Some languages which don't do this automatic garbage collection, they are able to save like this $5 billion per year in this conservative estimate. But it's a lot more, right? So when you tune, you can reduce your cloud computing cost, and also your response time is going to get a lot better. Okay.